Hello everyone. In this video, we are going to discuss about inductive proofs. Inductive proofs are the recursive proofs. Here, to prove S of n, we need to prove two conditions. One is basis. So here, we have to prove that S of I is true for some initial value. So here I is 1, but it depends upon the problem. Sometimes if the problem is if x is greater than or equal to 4, we need to prove something means the initial value of x is 4. So we have to choose the initial value based on the problem. So in the basis case, we have to prove the statement for some initial value. Then we have to prove the inductive step. This is a recursive step. So in inductive step, we have to assume that S of k is true. That is up to k. First k terms are true. So assume S of k is true. Then we need to prove that S of k plus 1 is also true. So if we want to prove S of n, we need to prove two cases. If S of I for some initial value I, if the statement is true, then in inductive condition we have to consider S of k is true and we need to prove that S of k plus 1 is also true. So in inductive, in basis case, we took n as I and here n is k, S of k is true. Then here we have considered n is k plus 1. Then consider this example. 1 plus 4 plus 7 plus dot 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 plus 3n minus 2 is equal to n times 3n minus 1 divided by 2. Prove this statement by mathematical induction is the problem. Means first we need to prove the basis condition. So basis means we need to take the n value is I, that is the initial value, so 1. So we have to consider the first term in the equation. So 1, left hand side of this equation is 1 is equal to substitute 1 in the right hand side of the equation. So we will get 1 into 3 times 1 minus 1 divided by 2. So if we solve this, 3 minus 1 divided by 2. So 2 divided by 2 is equal to 1. So both left hand side and right hand side both are 1. Hence the given statement is proved for the basis case. Now we need to prove. So to prove the base condition, we have taken I value as 1 and we have proved basis condition for this equation. Now we need to prove the inductive step. So in inductive step, we have to consider n is equal to k. So the equation becomes 1 plus 4 plus 7 plus dot 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 plus 3k minus 2 is equal to k 3k minus 1 divided by 2. So this equation, we have written this equation. In this equation, we have substituted n as 2. N as k. So 3k minus 2 is equal to k into 3k minus 1 divided by 2. So in inductive step, we need to assume that this statement is true. So assume that this statement is true, equation number 1. Now we need to prove k plus 1th equation is also true. So we have to consider n is equal to k plus 1. So we need to write the left hand side as 1 plus 4 plus 7 plus dot 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 plus the kth term is 3k minus 2 plus k plus 1. First term, second term, third term up to kth term, then k plus 1. So this left hand side of the equation should be expanded till k plus 1, k plus first term. So now instead of k, instead of n, we need to substitute k plus 1 in the equation, right? So instead of this n, we have to substitute k plus 1. In this equation, we have substituted k. Instead of n, we have substituted k. For the next one, to prove the statement, we have to substitute n as k plus 1. So 3 times k plus 1 minus 2 is equal to, instead of n, k plus 1, then 3 times k plus 1 minus 1 divided by 2. So now for this term 1 plus 4 plus 7 up to 3k minus 2, we can substitute equation number 1, right? Because here we assume that s of n is true for the kth term, that is s of k is already proved as true. So instead of 1 plus 4 plus up to 3k minus 2, we can substitute this equation. So k times 3k minus 1 divided by 2 plus 3k, we can expand this. So 3k plus 3 minus 2 is plus 1 is equal to k plus 1. We can simplify this also. So 3k plus 3 minus 1 is plus 2 divided by 2. So in order to prove s of k plus 1, we have to consider k plus 1th term. S of k plus 1th term is equal to the right hand side. So if you substitute kth term in the left hand side and plus k plus 1th term, means we can prove that the left hand side is equal to right hand side. So we can prove that s of k plus 1 is also true. So now we can simplify this equation and prove that left hand side of the equation is equal to right hand side of the equation. So k into 3k minus 1 plus take LCM. So 2 times 3k plus 1 divided by 2 is equal to k plus 1 into 3k plus 2 divided by 2. So now we can simplify this equation. 3k square minus k plus 6k plus 2 divided by 2 is equal to multiply these two terms. So we will get 3k square plus 2k, 3k square plus 2k plus 3k plus 1 into 2 is 2 divided by 2. So 3k square plus 5k plus 2 divided by 2 is equal to 3k square plus 5k plus 2 divided by 2. So left hand side of the equation is equal to right hand side of the equation. So s of k plus 1 is also true. So s of k plus 1 is also proved. So we can say that the given statement s of n is true, because here we have proved basis condition. So s of I is proved, and in induction step we have considered s of k is true, and we have proved that s of k plus 1 is also true. So that we can say that the given statement s of n is true. So the given statement is 1 plus 4 plus 7 up to 3n minus 2 is equal to n into 3n minus 1 divided by 2 is also true. Thank you.